All right, so here we go. Number 28. It says a number cube is rolled. So that means there's just what, 6 sides, right? All right, I want to find the probability that you get a 4 and you spin and get a C. So, you know, what is it? 1 out of 6, and then 1 out of 8. Yay, thank you. Wow, success. All right, I'm proud of myself. Very proud of myself. All right, very good. Again, listen, same situation. Let's go around the room again. All right, so Jolie, let's look at you getting the probability of a prime number. So again, I want you to, we'll just write down the numbers 1, 2, 3, 4, 5, 6. Tell me how many of those are prime. So which ones are prime? Tell me.
1, 2, 3.
Everybody says 1. Okay. But 1 is a unique number because in order to be prime, you have to have 2, right? And 1 only has 1 number. Do you hear me? Okay. So how many primes are there? Right. So we're doing 2 events again. I really wish you would do this. All right. And so what's the probability of getting a prime number again? 3 out of 6. And then what's the probability of getting a consonant? Well, let me check. Consonant, remember there's vowels and consonants. Vowels, A, E, I, O, U. Remember that? All right, so now tell me how many consonants you see. Yeah, you see that, right? And so we would say 6 out of what?
8.
6 out of 8, guys. And then everybody reduce the fractions. So 3 6 reduces to, and 6 8 reduces to, how many? 6 8 reduces to what? Don't be sorry. Come on. Put your hand down. She knows.
3/4.
Yes, 3/4. Okay, so now probability would be what? No, you don't need a calculator. Come on, you're asking me what's 1 times 3.
3.
And then 2 times 4. Jolie, 2 times 4.
8, sorry.
Jolie, are you with me today now?
Yes. No.
3 8. 3 8. Okay? Shh. Don't listen. This has been a problem now. So don't come in interrupting. All right, what? Aren't there 6 consonants? The highlighted? Is that right?
Yeah.
6 out of 8. All right, KK. I want number 30. Again, 2 things are going on. What's the probability to get less than 3? Shh, shh, shh. KK, what's the probability that you get less than 3? Well, what are we doing? On this problem, it says you're rolling the die and spinning the spinner. So here's your die over here, KK. Come on, KK, tell me. What's the probability of getting less than 3? Out of what? Yes, 2 out of 6. And then what's the probability of getting a B? Yes, ma'am. Good job. All right, KK. All right, tell me about 2 6. What does that reduce to? Good job, kiddo. So what's my final answer? Yay, 1 out of 24. KK, I just don't think that's that hard for you. Right? But you got to tell me, KK. All right, everyone else is participating. You participate. All right, Molly, you get to read 31.
On which night they had the most homework. If a student is selected at random, what is the probability that he or she does not have the most homework on Thursday night? So,
So we want the probability that she does not have the most homework on Thursday night. All right. So now, to me, when I'm looking at this, I'm looking at Thursday. Do you agree?
mm-hmm.
Right. And so far, I see how many people?
Do I have to add all of those up?
Yeah, add those up real quick. I didn't do that.
Okay.
And I'm waiting for extra help too. I need someone to confirm.
I got 500.
Did anybody else get 500?
Yeah.
All right, so that's the total. All right, so now you got to be careful here because it says, what is the probability that she does not have the most homework on Thursday night? All right, so what do I do if I do not want to have the most homework? What would I have to do?
You'd have to divide the.
Now remember, this in your fraction, Molly, come on. This is what you want. All right, this is what you want. All right, so I want the number of students that do not have the most homework. All right, I don't like the negatives. All right, so what I want you to do, Molly, is I want you to tell me how many kids have the most homework on Thursday.
105.
105. So this would be the probability of the kids who have the most homework on Thursday. But I want the kids who do not. So if 105 kids do, then how many do not? How would I figure that out?
Would you?
Say it. It doesn't matter. Just tell me what you're thinking, kiddo. That's how you learn. You got to say things.
Would you subtract it
From what? Yes.
from 500?
Yes. Very good. You would subtract it from 500. All right. And tell me what that is.
395.
That is correct. So we could say 395 out of 500. The other way everybody should say is they could just add all these numbers up. Do you agree? And not the Thursday. Do you agree with that, Molly?
Mm-hmm.
All right, now we have to reduce this.
Uh,
So one way is just type it on your calculator as 395 ABC 500 and tell me what it is.
okay.
Now remember, I can't get out. I want you doing the problem. I don't want you writing down my answer. You should be doing it yourself, like everyone else.
I got 79 over 100.
Anybody else get 79 over 100? All right. All right, that wasn't bad. All right, Avery, talk to me about 32, please. Read it. Okay, so that was kind of sneaky. All right, what's the matter? You okay? What? You don't need your calculator for this one. It's too easy. All right, then you can look at it. So let's start out with, what's the experimental probability of getting a 3? I'm sorry, the cube lands on the number 3. Yeah, it lands on 3 5 times. So what would be the experimental probability? How much? I don't know what that means. Where did you get 15? Where did you get 15?
No.
What you did was you threw the dice 25 times. You threw the dice 25 times. How many times did it come up? 5. 3. So what is the experimental probability? That's it. 3 out of 25. The experimental probability for rolling a 3. Hold on a minute. You rolled the 3 how many times? Thank you, Ashley. 5 times. So it's what again? We didn't roll. We rolled the 3 5 times. So what's the experimental probability of throwing a 3? So what's the experimental probability? Yes, 5 out of 25. I'm sorry. I wasn't sure if I heard you correctly. And then that reduces to what? 1/5. All right. Now, what is the theoretical probability of throwing a 3? What's the theoretical? If you take the dice and you throw it, what's the theoretical probability of getting a 3? Well, how many 3s are on the dice? And how many are there on the die? Numbers. Right, so this is called the experimental probability, and the theoretical probability is what should happen. 1/6 is the theory, all right, or the theoretical probability. This is the experimental probability. Do you agree with that? So what they wanted you to look at here is say that the experimental probability was a little bit greater than the theoretical, but it wasn't that far off. Do you agree with me on this? 1/5 and 1/6, not that much difference. All right, now, again, I want some hands if you're not understanding what I mean by theoretical and experimental. What? No. So that would mean you're getting the same number each time. All right, that's not what it's saying. Right, that's it. Because what you're trying to do when you do experiments is, let's say you don't know what the probability is. You just do a bunch of experiments, and then the more experiments you do, the closer you'll get to the actual probability. Right? In theory, it should be 1 out of 6. But in our experiment, it was only what? 1 out of 5. What? The theoretical is what should happen. When you have a dice with 6 sides, you should get a 3 how many times? 1 out of 6. How many sides on the dice? And how many of them are 3s? 1. That's the theoretical probability. You have a 1 in 6 chance. Do you agree with that? KK, am I making sense? All right. Ashley, help me out with this one. Okay, tell me. So what would that be? Well, it's okay, Ashley. How many times? Okay, so now the experiment, remember, is what you got during the experiment. So how many reds did you draw in the experiment? Are you sure? 4, right? Do you agree with that now? You did 4 out of how many times? Right, 4 out of 30. So your experimental probability is just 2 out of 15. Yes? That makes sense? Right, right. Now, this is the experimental probability. What's the theoretical probability, Ashley? Of drawing a red? How many red tokens are there? 2 out of 10. Exactly. All right, which is 1/5. Do you agree with that? That's the theoretical probability. Tell me again. What's the matter? Because it says up here, in the bag, there are only what? 2 reds out of what? 10. You see what I'm saying, right? So to me, 2/15 is not far off from 1/5, right? So it's pretty close. What? Because in the bag, there are 10 tokens. And there are how many reds? 2. Yeah, that's the theoretical probability. All right, what should actually happen? Okay, everybody okay? All right. Now, it says, suppose Lisa repeats the experiment 250 times. About how many times can she expect to draw a green? All right, so Luca, what am I gonna do for this? Yes. Yes. What's the theoretical probability of drawing a green? What's the theoretical probability of drawing a green? Right. So you should get it a green 4 out of 10. Well, 4 out of 10 times what? You're correct, but tell me what number should I put here before I reduce? Right. Right. 4 tenths, the theoretical probability times the number of outcomes will tell you how many you should get. How many greens should you get? How much? 100. You should get 100. That is correct. Does that make sense? All right, which was like problem number 1. All right. So here we go. 35. Let's hear it. Cole, go. Three events.
Then I put
2, 4, 3. That's exactly correct. All right, I'm making progress. 2, 4, 3. So how many outcomes? What's 2 times 4? Times 3. Yeah, 24. You see that or not? Right? 2 times 4 times 3. There are 24 outcomes. Does everybody agree? But the problem is we have to draw a tree diagram.
It took me an hour.
Yeah, seriously.
What? It took you an hour.
Yes, it
So if
does.
I try to do it right now, it should take me like close to an hour.
Yes, yes, it really should. Even copy and pasting took a long time.
Are you kidding? Watch.
Copy and paste, I can't count.
Cotton, denim,
You want to see?
right?
This is my
No,
word that took me
I
7
don't.
hours.
1, 2, 3, 4. Uh-oh. Right, because we have to do small, medium, and we have to do large. Small, medium, large, and extra large. Small, medium, large, extra large. All right. Oh, yeah, X. All right. So now, come on, you just take that, copy it, paste it. What's wrong? And then what? We have to do
BDR.
blue, black, and red. Except I don't like the BL. That's bad colors. All right. So now we're going to come down, and each branch here has to be done what? 3, right? So I want blue. And I'm just going to spell blue. And then black. And then red. And then copy. And then paste. Yeah, I'm saying, how did you, take you an hour to do this? Right, so on each one of these,
No, I did it right.
there you go. Put it right up there. Paste the other one. Right in there. Paste. Good with that? Now this one's a little not so good. So we can look at this one. There you go. Just shrink it down a little bit. That wasn't bad, right? So now if you had to list them, you would say, and I'm not asking you to list them, but you could say what? CS blue, then what? CS black, and then there you go. And then CM blue, CM black, CM red, CL blue, CL black, CLR. Does everybody see that, right? That wasn't bad. Everybody good? Any issues? All right. Now it says, how many skirts are medium and blue? How many? 2. Now let's say we didn't know. Look, you can pick what? The fabric, you can pick the size, and you can pick the color. You agree? How many fabrics are there? 2. Mediums, how many? 1. Blue, 1. There you go. That's how you can do that. Simple, simple. All right? Really simple. All right? Here we go. Let's try, well, let's just go ahead and finish this. If the options are chosen randomly, what is the probability that the customer will choose a large black denim skirt? 1 out of 24. All right. All right, here we go. Number 36, another tree diagram. So Ashley's packing it for a trip. She wants to pack enough clothes to have a different outfit for each day. She's packing 1 pair of jeans and 1 pair of shorts and 1 skirt. So she has what? 3 options. So again, at the top, J, S, H for short, and SK for skirt. And then she has how many colors? She has how many shirts? 3 shirts also, right? So 1, 2, 3. Red, striped, button. So here we go. Copy, paste, copy, paste. Now, was that it? And what else? She wants to, she needs to take a few clothes, jeans, shirts, and skirt. She also has 1. Wow, so that's it, right? That's all she has. So there are how many possibilities? 9, right? So is she going to be able to wear a different outfit? No. 9 outfits. Easy as that. What? Yes. Yes. No, good. All right, there you have it. All right, here we go. Eddie, you tell me about 37, please.
Mr.
Gerber, yes.
Class is making snack baskets for 800. The baskets can be ordered in red, blue, green, black, and white. The basket is for delivery with red and green bread, with oatmeal chocolate chip, peanut butter, or sugar cookies. Determine the number of baskets in the tree diagram.
Without a tree diagram. So how many events do we have?
I did 3 events.
3 events.
And then the first one's 5. And the second event is 2. And then the third event is 4. And then make it 4 and make it 40.
Wow, okay, thank you. All right, I feel good. 40 events, 40 outcomes, I should say. All right, Jackson, number 38. Yeah, so see, this was kind of tricky. What did you think? What's the probability of getting a 9? Were you able to figure this out? Good. How many outcomes were possible? Well, there are 2 events. How many possibilities on the first event? This is event number 1. So what are your possibilities there? Come on, how many events in this guy right here? No. Zeb, help him. In this event, how many outcomes are possible? 5. On the second event, there are how many? 3. So there are a grand total of how many different outcomes? There are 15 outcomes. All right. Now, here's where you have to be careful because you're supposed to organize the numbers. All right. So to organize the numbers, let's start with the small first. 4, and then a 1. 4, 2, 4, 3. 5, 1, 5, 2, 5, 3. 6, 1, 6, 2, 6, 3. 7, 1, 7, 2, 7, 3. 8, 1, 8, 2, 8, 3. Those are our numbers. All right. Does everybody see that? And if you add those up, there's 15 choices there, which is what we said. Now the question, it says the sum has to be 9. So how many of those numbers add up to 9, Jackson? 8 and 1. Right. So it'd be what? What's the probability of getting a 9? Yes, 3 out of 15, which is 1/5. All right, 3 out of 15, which is 1/5. Everybody okay with that? All right, this is what I mean by organizing. I can't tell you the importance of being able to do that. All right, KK, you see how we did that? All right, 39, Tyler.
That contains 4 yellow, 5 red, and 9 blue marbles.
Okay,
Marbles selected. So find the probability of drawing red or blue marble.
so what would that be?
So red and blue adds up to 14 out of 18.
Yeah,
7 over 9.
beautiful. All right. KK, number or letter B, what's the probability of drawing a yellow marble? Yes, I don't know what you're waiting on. 4 out of 18, correct. Now reduce it. Two. Yes, 2 over 9. And listen, right now, I don't care about C, just cross out C. Oh, is that it then? Okay, that's it. Now listen, all I want you to do is just practice these problems. I told you, you should be highlighting the ones you don't know or the ones you made a mistake on. All right, that's what you should be doing. All right, so that's it. Now your time is to study quietly. All right, Molly, did you have any last questions, kiddo? Does that make
No.
sense to you?
Yes.
All right, tomorrow's a big day. All right, I want you to do well. All right, so good luck. And I will see you tomorrow, okay?
Okay.